Hello, welcome back. Today let's try to solve another Leetcode problem, 221, Maximal Square. So we are giving a m times n binary matrix. It means inside the values can be 0 or 1. So we need to calculate the maximum square or inside the matrix. So for example, the red area it is 4 because 2 times 2 it is 4, and also the green area it is also 2 times 2 it is 4. Let me first explain my idea in the whiteboard and then go to the code editor to finish the coding. Yeah, let's check the variables first. I mean the limitations of the variables. M equals to matrix.less and n equals to matrix I.less. It means the rows and columns always maximum 300. Yeah, it means like this matrix we cannot use brute force. If we use brute force, we need to loop through rows and columns. It will be m times n, and then for each of the places we need to calculate the maximum. It is another m times n. So in total, the time complexity is m squared n squared. Yeah, if the value of m or n is 300, so it means 300 to the power of 4. Of course, that will be time limit exceeded. So we have to use some tricks to solve the problem. So for this one, it is a matrix, and if we can use the previous state to calculate the current state, normally this is a dynamic programming problem. Let me first go to the whiteboard to explain my solution, and then go to the code editor to finish the coding. As you can see this matrix, from here, this is we need to, calculate, basically, we need to calculate the length of the side of the square. So if we know the length of the side, this side is 2, basically, we know the final result because it is just 2 times 2. Because we just need to calculate the square inside this matrix with only 1. Zeros we don't care. So how can we use the current previous state to calculate the current state? So for example, this one is our current, is our previous state. If this one, we know that this is a 1, so from here it is 1. So when this one compared with the one to the left side, to its left side, it is another 1. And here, to the bottom side, there's another 1. Now, all these values, these 3 values, is the previous state. So how should we calculate the current state? So we need to check if this number is 1. We need to check, can those numbers become a matrix? How it can become a matrix? We need to check the minimum of all those values. If the minimum of all those values is 1, for example, here the minimum of this value is 1, the minimum of this value is still 1, and here it's still 1. It means we can combine with these values to become a 2. It will be the minimum, it is 1 plus 1, it is a 2. So this 2 means the maximum length of the square already becomes 2 when it comes to here. Because except for this one, all others, this is 3, the minimum is 1. Yeah, so it means it can become a square, the length of the side can become 2. Yeah, now let's calculate the next one. For example, this one. So the minimum of this one, and this one is still 1. So here also updated to 2. Now let me put a 2, and here also I put a 2 here. Now let's calculate this area. So this area is 0. It doesn't matter. So this is 1. So the minimum of them, 1, 1, and 0, it's still 0. So here will be just be 1. It will not calculate. So it will just be 1. It will be here. So what if this number is 1? Let's put a 1 here. Now let's put also another 1 here. Let's check how can we update the side of the square to 3. So up to now, here this is 2 and this is 2. And if this is 1, it's still 1. But if this is 1, according to our calculation, so here is a 2, here is 1, and here is a 1. So we are gonna calculate the minimum. So this one will be 1 plus 1 because this is a 1 plus 1, it is a 2. But how should we know we can calculate the minimum to get the final result? It must have some representations for each of the numbers inside the matrix. So for example, here this number 2 means from this point to this point, it can become a matrix. It will start from the bottom to the up like this way. It's gonna become a matrix of 2. It is like this. So for here, this number 2, it means from here to here, it can become a matrix. And also for this number 2, it means from the bottom to the top, it can become a square. So up to now, if this is a square at this area, and at this area it's also a square, and this area is also a square. So what about this one? So this one will also be the minimum of these numbers. It means already it becomes a 2 plus this one. It can become a length of 3. So here will be updated to 3. We can also understand the question like this. So here this 2 means this matrix, there's a matrix of 2. So this matrix, the length of the side is 2. So for here, this 2 means it is inside, but here it can be extended to a length of 2 because this 2 means basically to the top, to the left, and to the triangle diagonal area, it's gonna be 2. So let's prepare this one. And here, for another 2, this 2 means basically this area is also a 2. I mean, it is inside, but we don't need to consider. And this is also inside, but this area is 2, this area is 2. So how should we update the last one? So if it is 1, it means all the areas inside it is 1. So it can become a 3. So inside it is always be 1, and this is inside always be 1, and this inside always be 1. So this 2 actually has meanings. It means inside is always be 1, and this 2 it also means inside always be 1. And this 2 inside always be 1. This is why here gonna be 3. After calculation, we got the maximum length of the square is 3. So we just need to return 3 times 3 if this is 1 and this area is also 1. Now let's go to the code editor to finish the coding. Actually, the coding should be much simpler if we understand the whole process of the DP matrix. Now let's prepare some variables. R and C should equal to the length. So the R should be length of the matrix plus 1. Here, I'm going to prepare some paddings. If I don't prepare, I have to calculate the first row and the first column, and then I need to update from here. Now, I'm going to prepare a padding. So the padding row and the padding column should always be zeros. It will save my calculations. I just need to loop through the matrix directly. I don't need to prepare this first row and this column because it will always be 0. Now I also prepare a column padding, so it will be length of matrix 0 plus 1. Now I'm going to prepare the DP array. So inside it will be 0 padding. So I'm going to put it 0 inside because for my calculations I only consider the ones. So the padding 0 doesn't influence my final result. So the padding should be 0 times C for R in range capital R. So this is my DP array. Now I can start the for loop for the DP array. So for R in range 1 to R, and for C in range 1 to C. Let me explain the padding a little bit. So from here, I just need to prepare some paddings. These paddings will always be 0. This is just for the easy calculation of the matrix. So all these areas will be 0, and I'm going to start from this one first, and then I'm going to check row by row and get the final result. So the final result will be, I will be use a result to check if I got the maximum result at a position. Now let me also prepare a result variable. So the result will start from 0 because it can be 0, for example, inside this testing case. So the result is 0. So the result will be 0. And now I'm going to update my DP array. So the inside the DP matrix, so the DP R and C should equal to the minimum of DP. Basically when I'm calculating, for example, this one, it will be the minimum of top, bottom, and diagonal area. It's this one. So I'm going to calculate these three numbers basically. So it will be the dpr c minus 1, dpr minus 1, c, and dpr minus 1 and c minus 1. And we need to plus the matrix. So the matrix should be R plus 1 and C plus 1. This is because we prepare a padding plus 1 for the column and also for the row plus 1. So for the matrix, we need to minus 1. So after updating the DP array, we need to get the result. So the result should be the maximum of result with DP R and C. Now we just need to return the result times the result because we need the area. We need to calculate return the area. Area is the side times the side, the length of the side. Now let me run it to check if it works. Unspotted. I didn't use some seconds. I need to. It's not this matrix. I need to check. Basically, because inside it is always be strings inside. It is not numbers. So I need to check. And here there's also something wrong with my DP. Basically, for updating the DP array, I have to check if this value is 1 or 0. If it is 1, I'm going to update. If it is not 1, I'm not going to update it. So if a matrix R minus 1 and C minus 1 equal to string 1, I'm going to update it, and this will be plus 1. So here the DP array will need to plus this 1. And after that, I'm going to update the result. This is basically, I'm going to check this one. If this is a 1, I'm going to update it. While I'm updating, I need to compare with the three values from the top, left, and the diagonal areas. The top left, this one. Now let me run it to check if it really works. As you can see, it works. Now let me submit it to check if it can pass all the testing cases. And by the way, the time complexity is OM times N. It is much faster, as you can see. It's 71% of all Python 3 submissions because this is just OM times N time complexity, and the space complexity is also OM times N. Thank you for watching. See you next time.